We were doing permutation combinations. Started this chapter and we discussed arrangements. First, we did factorial notation. Using factorial notation, we did the arrangement thing. Did these examples. Few questions from exercise. Now permutations. In the last section, you learned that you had three letters A, B, and C, three spaces to fill. Then the number of ways to fill the spaces is 3 into 2 into 1 or 3 factorial. Now consider that having eight letters A, B, C, D, E, F, G, H, and three spaces to fill. So the first space can have 8 options and then 7 and then 6. We have to choose out of these 8, but there are only 3 spaces. Let's say you have 8 letters and you can put a password of 3 letters. So these will be different ways, number of ways you can make that password. So different arrangements of letters are called permutations, and this could also be done as 8p3. Like either we select 8 options for the first box, then we have 7 options, then we have 6 options, or we write 8p3. 8p3, and if you could have a look on your calculator, you'll find the button saying NPR and NCR.
NPR and NC. Okay.
This one is permutation, the other is combination. We'll get to that in the next exercise. So 8p3.
NPR.
36.
Where would the NPR button be? Oh, I see it. It's right below right above the multiplication, right?
Yeah, I have that on multiplication and NCR on division.
Mm.
Okay, now we put permutations where the combinations will exactly matter, where the order will matter. If the order does not matter, we put combination. Okay, that was one example. And formula for permutation, general formula is that NPR is equals to n factorial over n minus r whole factorial. In this case, that was 8p3. So 8 factorial over 8 minus 3 factorial. You will have calculator with you. If not, this is how it's going to be. So 8 minus 3 is 5 factorial. So that is 8 into 7 into 6 into 5 factorial over 5 factorial. So this cancels out. And 8 into 7 into 6, we get 336. Number of ways. So in permutation, order will matter. For example, I'll just give you an example. If there are 3 friends A, B, and C, and you're going to select 2 out of these for a picture, and if you say that we stand A, B, or we stand B, A, you say that this is a different choice. So you'll have 6 different ways. You can have 6 different type of pictures. But if it does not matter, they're standing next to each other, then that will be a combination. And 3C2 gives only 3. There are only 3 different options. The ABBC or ACCA or CBBC. So if you say left right does matter, so it will be 6 different options. And if you say left right will not matter, so it is either AB or BA, that's one thing. Like one says that Abdullah is having picture with Basit. or Basit is having picture with Abdullah is one and the same thing. They're both in the frame. If that's one, it will be combination. If the order matters, that will be permutation. And definitely in case of password or anything else like that, combination matters. So that's where we use permutation or where we use combinations. So in permutation, order will matter. And 0 factorial is 1. To explain why 0 factorial is equal to 1, consider finding the number of permutations of 5 letters taken. 5, 4, 3, 2, 1. And we just plug in that in the general formula. And we know that this is at least one pattern. This is the first choice. So either you get 0 factorial, that still equals to one choice. Worked example. A security code consists of 3 letters out of A, B, C, D, E, F. So out of these 5, it is 3-letter code. Out of these 6, followed by 2 digits selected from these. Okay, security code is 3 letters from these and 2 digits from these. Those were 6, and this is 1, 2, 3, 4, 5. And this is a password, so order will matter. So out of the 6 letters, we are selecting 3. So that's 6P3. And out of the remaining 4 numbers, we are selecting 2 numbers. 5, 6, 7, and 9. Out of the 5 numbers, we are selecting 2 numbers. So that's 5P2. And when you multiply with them, you get total number of outcomes, total number of possible passwords, that is 2400. Clear till now?
Yes. Yep.
Okay. The first 3 spaces must be filled with 3, 6 letters. Exactly same thing. Another worked example, find how many even numbers between 3000 and 4000 can be made using the digit 1356979. 135 135,679 if no number can be repeated. Okay, we are making even numbers, and the first number must be 3 and the last number must be 6. That's one option, that's one choice to make it even. And 975. Okay, now this time there's no other option because only even digit is 6. So 6 has to be at the end to make it even. Second thing, it has to be between 3000 and 4000. If I put 1 in first, that will be actually 1000 something. That is outside the given range. If I put 5, that will be more than 4000. So 3 and 6 are fixed. Once we do that, what are we left with? 3 is done, 6 is done. We are left with 1, 2, 3, 4 choices. So out of those 4, we can now select only 2. So that is why we are making 4P2. Because order and arrangement does matter here. So 4P2. This is your answer. 12 different possible codes can be made, numbers can be made if it has to be between 3 and 4000, and if it has to be even. The second method, we just plug in number of choices. We have no other choice other than selecting 3, no other choice selecting 6. And for this, you have only one choice. For this, you have only one choice. Now, out of those remaining 4 choices and 3 choices, now we just multiply them. 1 into 4 into 3 into 1. Number of choices multiplied with each other, you get 12. Third method is we list out all the possibilities. And if in thinking process you miss out even one, you lose all the marks because that is not correct. Method 1 and method 2 are always advisable. Okay. Another one
Like
that you have
work
to,
steps in like the working and stuff. So if we even if we miss like one step in the working, then we won't get the whole answer right, even if we get the final answer.
like in method 3.
Yes.
Okay, first of all, it is not going to be that straight or simple. And like if someone is trying to list all those, that also gives the impression that they don't have the knowledge about permutation or combinations.
Okay.
So, secondly, if we have ABCD parts or something related to it, and we just lose the first one, definitely we are unable to solve the remaining question.
Okay.
If numbers or letters are less or small, you can go for manual calculations, but like this, I won't consider 12 different combinations as less numbers. Now solve NP2 is equal to 300. So you just put that in the formula. So NP2 is n factorial over n minus 2 whole factorial is equal to 30. Now general formula must tells us NP2 is equal to 30. So first one n factorial over n minus 2 whole factorial is equal to 30. Now how do we proceed? First number must be n. The other is 1 less than n. Another 1 less than n over n minus 2 factorial is equals to 30. Now we get rid of this. So that's n square minus n minus 30 is equal to 0. Now 30 is 5 into 6. N square minus 6n plus 5n minus 30 is equals to 0. N common n minus 6 plus 5 common n minus 6 is equals to 0. N plus 5 n minus 6 is equals to 0. N is equals to minus 5 and n is equals to 6. Now this is the answer because number cannot be negative. Possibilities cannot be negative. B part says, okay, try B part. Can you do that? Can you do B part?
Can you hear me?
I can hear you now.
Okay. Yes, I can do B part.
Okay, try this and find n.
So I'm getting m equals to 12.
N is equal to 12, yes. Okay. Exercise 10.3. Without using calculator, find the values of each of the following. Let's try any two of them. Going for the first one, 8P5 without calculator. This is exercise 10.3, question 1A, 8P5. That is 8 factorial over 8 minus 5 factorial is 3 factorial. So we would know 8, 7, 6, 5, 4 into 3 factorial divided by 3 factorial. This cancels out. So now I know this is 8 sevens are 56. 56 into 6 is 336. I remember we just did that. So 336 and 5 fours are 20. 336 into 20, that is 3360 into 2. And 3360 times 2 is 0, 2, 1, 6, 1, 7, 6. So this is 6, 7, 2, 0. 10.31a, 10.31a, 6, 7, 2, 0. Well, C is a very large answer. Try any from B or D. Oh my God. Oh yes, it said without using calculator and following. Use the key this on your calculator, check your answer. Okay, that's a double check. I just checked the answer from key. This was 8, E5 getting 6720. Try B part.
Okay.
And if you just look at D part, 7P7 is actually 7 factorial. We did factorial in the very first exercise of this chapter.
$360.
1B, 360. Okay. Find the number of different ways that 4 books chosen from 6 books can be arranged on a shelf. So 4 books being selected from 6 books. This is 6P4. And I'm using calculator, we get 360. 360. Try question number 3.
15,120.
15,120 is correct. Okay, number 4 says there are 8 competitors in a long jump. How many different ways can the first, second, and third prize? So we are selecting 1, 2, and 3 out of 8. So 8P3. 8P3 is 336. Fifth says find how many different 4-digit numbers greater than 4,000 can be formed. Now there's a restriction. This is question number 5. 1, 2, 3, 4, 5, 6, 7. So total numbers 7. 1, 2, 3, 4, 5, 6, 7. But it says it has to be more than 4,000. So to be more than 4,000, and how many 4-digit numbers? So 4-digit number is 1, 2, 3, 4. For this first box, I can put in these 4 digits, or else it will not be more than 4,000. So I have 4 choices for this box. And once I've made my choice, definitely there's one number going in this box. If I choose any one of these, let's say this, now I'm left with 1, 2, 3, 4, 5, 6 choices. So 6, 5, 4. What do you say?
654.
Yeah, once I've made my choice for the first box, now I can put anything in the second box. And once the number goes there, I'm left with 6 numbers. And once the number goes there, I'm left with 5 numbers and then 4.
Okay.
So I would say that this is 4 into 6 into 5 into 4. That's 480. I just hope that is 480. Yes. And in case of permutation, we can also write it like this, that these are 4 into out of remaining 6, we need 3 numbers. So 4 into 6p3 is 120, and that's 480 again. We write it either way, we get same answer. Try question number 6. Is it working out?
Yes.
Okay.
I'm getting 18.
That is correct. Question 6, 18 is correct. A four-digit number is formed using four of the eight digits. No digit can be used more than once. Find how many digits, four digits can be formed if there are no restrictions. There is not restriction. So out of these eight, we are selecting four and the order matters. So 8P4 is 1680. 1680. Okay. B part. It has to be odd. So these were 1, 2, 3, 4, 5, 6, 7, 8. And we need four-digit number. And if it has to be odd, I can have 1, 2, 3, 4, 4 at the end. So these are four choices. Once the choice is made, for this first box, I'm left with seven choices, then six, then five. So 7 into 6 into 5 into 4 gives me 7, 6, 5 into 4 gives me 840. This is method 1, or our thinking process could have been that we just have four options for the last one, and out of the remaining 7 we can choose any 3. So 7p3 into 4 is again 840. 840. Try C part. The number is greater than 6000. Is it working? C part?
Yeah, I think so.
Hmm. Four-digit number greater than 6000. Still working? 7C.
I think the answer would be 630.
That's correct.
Okay.
Because to make it more than 6,000, these are the three options which we can put here, 6, 7, or 8. So three choices. Once the choice is made, we're left with 7 digits, then 6, then 5. So 3 into 7 into 6 into 5 is 630, or 3 into 7p3 is 630. 630. Try D part. One more restriction, it has to be greater than 60 and it has to be odd.
So I guess we could break it into cases. So like case one would be the first digit is 6. And then case two, the first digit is 7, or the first digit is 8, and then we could just add
Yes, very
those.
good.
Okay.
Very good. We'll break it into cases. So it has to be more than 6,000. So if we select 6 here and it has to be odd, so there are 4 choices in the last one and 2 numbers done out of this. So this is 6 and 5. So 6 into 6 into 5 into 4 is, no, what did I do? Sorry, I fixed a 6 at the front and that's one choice. Fixing 6 here, and there are 4 different choices at the end. So this is 120. Then we fix 7 at front. If 7, this is for first choice. And once 7 is done, I have 3 options for the last number to make it odd. So 6 into 5. That's 90. And if we make the first digit 8, that's again one choice. And if that's 8, I again have this much. At the end, odd numbers, and then out of the remaining 6, we have this choices 120, and total is 120 plus 120 plus 90 is 330. 330. Question number 8. Numbers formed using digits 3, 5, 6, 8, and 9. No digit can be used more than once. Find how many different 3-digit numbers can be formed. So question 8. Total are 1, 2, 3, 4, 5. And we're selecting 3. So 5p3 is 60. And then B part says number using 3 or more digits can be formed. Number using 3 or more digits can be formed. Okay. So this should be 5p3 or 5p4 or 5p5. 60 and 120 and 120. 120 plus 120 plus 60 is 300. Any doubt in this 5p3, 5p4, or 5p5?
No.
360. 60 and 300. Try question number 9. Hmm. Number 9.
I'm getting 720.
720 is correct. I made my first attempt. I'm not getting 720. Can you explain how you did that?
Okay. So basically, I just identified the even digits in the list that they gave us. That was just 2, 4, 6, and 8.
Sorry. Even how many even I missed out this information. I
Um,
did without that, and I was getting 14 something. Okay, that makes sense.
okay.
I missed that information out. Okay. So number 10. Now that's expansion of the formula again. This is NP5 is equals to 720. N factorial over N minus 5 factorial is equals to 720. Now that will be N, N minus 1, N minus 2, N minus 3, N minus 4, and N minus 5 factorial over N minus 5 factorial is equals to 720. Are we going to go through this large? Okay, maybe calculation. Or what if I just try hit and trial? This is NP5 is 720. So if I just give it a try, I'm trying 5P5. 5P5 is 120. And then I try 6P5, that's 720. 6P5 is 720, therefore N is equals to 6. NP3 equal to 7n into n minus 1. That is going to be lesser calculation. N factorial over n minus 3 factorial is equals to 7n into n minus 1. n, n minus 1, n minus 2, n minus 3 factorial over n minus 3 factorial is equals to 7n square minus 7n. N square minus n into n minus 2, 7n square minus 7n. N cube minus 2n square minus n square plus 2n is equal to 7n square minus 7n. N cube minus 3n square plus 2n equals 7n square minus 7n. N cube, so now this is 3 and 7, 10. N square 7, 8, 9. N is equals to 0. Taking out n common is n minus n square minus 10n plus 9 is equals to 0. So multiplying, I'm getting 9. So 9 is 1 into 9. N square minus 9n minus n plus 9 and stays there, n into n minus 9 minus 1 n minus 9 n minus 1 into n minus 9 is equals to 0. So n is equal to 0, n minus 1 equal to 0, n is equal to 1, and n minus 9 equal to 0, n is equals to 9. So either n is 0, 1 or 9. Then B, n is 9. So it can't be 0 because NP3, they're selecting minimum 3 numbers. So it cannot be less than 3. So this is 0. And this is also rejected because these both are less than 3. So n is 9. N should be greater than equal to 3. Therefore, n is equal to 9. Try C part. 10C. N P5 over N P4 is equal to 3. I think hit and trial using calculator would be better choice for this one.
Okay, I'll try it in trial.
What is the first value you'll try? Smallest first value of n. What could that be?
Smallest first value, I could maybe try 7.
See, we have NP5 and NP4.
Yeah.
So at the bottom we have 4 and 5. So it cannot be less than the number at the bottom.
Um.
So I cannot try 4P5. It has to be either equal or more. So I'm bound I cannot try 4. I have to try 5. So 5P5 divided by 5P4. And then the second attempt, then the third attempt. I'm getting answer in the third attempt.
So we're doing 5P5 and 4P4.
No, n has to be same. That's n. That's n in one question. So n is same. If we try 5p5, this is 5p4, and we check what we get. Then we make the second attempt. 6p5, 6p4. We cannot try 4 because I cannot write 4p5. N
Okay.
has to be equal or more than that number.
Okay.
If you try the number less than 4, you'll automatically get math error in calculator.
For the 6p4 and 6p5, I'm getting 2, so that's not right. So the next highest would be 7.
Yeah.
And so 7p5 is 2520, and 7p4 is 840, so that's just 2520 over 840, and yeah, it's 3.
So just punch in this as whole and calculator as ones. One time punch, you'll directly get 3.
Okay.
So n is equals to 7. Question 9, question 10c is 7. Okay. So after permutation, we're moving on to combination and probably the last subtopic. You have already investigated the number of ways of arranging 4 different books in a line. So if the order will matter, we will write 4p4 or 4 factorial, and we're going to get 24 as answer. But if you are writing combination and you're saying that the order won't matter if the 4 books are next to each other, you'll get 1. Like this is blue, red, orange, green. In any order, you will say that all these 4 books are there, so the order won't matter. So that's only one choice. 4p4 gives me 24, and 4c4 gives me 1. That is the main difference between combination and permutation. Combination is a selection of some items where the order of the selection does not matter. So for combinations, order does not matter. Consider the set of 5 crayons. To find the number of 5, find the number of different ways of choosing 3 crayons from set of 5. We can use 2 methods. First of all, look at this general formula for combination. There's one difference. This r factorial at the bottom is being multiplied for combinations.
And that R basically changes it so that it's also with different like combinations, so like different things joined together.
Yep. So we just had those colors and we made all this selection. So order is actually order does not matter. This is like yellow, red, and violet. So anywhere else we don't have it in different order, like yellow placed somewhere else, red placed somewhere else. So we only have these different choices. So these are 10 options. So if the order would matter in this case, we'll get 60. We'll have 5p3, that is 60. But the order does not matter. We're just making a selection of 3 out of the total 5. So 5c3 is 10. For example, your school offers you 5 subjects and you select 3 out of them. So that won't really matter what order you're taking, but you're taking 3 different subjects. For example, you're taking physics, chemistry, math, biology, and ed math. So if you're taking any three out of these, there are 10 different possibilities. Like you're taking physics, chemistry, math, and chemistry, physics, math is not different. That's same. So order will not matter. So you'll get 10 different choices. Now, I never recommend going for manual. If even in thinking you miss out one, it's going to be incorrect. So P with C with B, P, C, and A, or we can have physics with math with bio. So I'm just thinking and writing. So this is a better choice that we understand the use of combination and permutation. If this would have been permutation, physics, chemistry, math, or math, chemistry, physics would have been different options and it would change to 60. Okay, then general formula for combinations is n factorial over n minus r factorial into r factorial. Okay,
So the order just doesn't matter.
yep. A team of 6 swimmers is to be selected from a group of 20 swimmers. Just like if there was a class of 20 and 6 students need to be selected without any order, random order, you just start picking them up. So 20C6. Just punch 20P6. If the order would matter, what do you get?
I'm getting it's a really big number.
Yeah, it's a
Um
too large number.
yeah.
So when order matters, it looks like that. When it does not, it is 38,760. Another worked example, the diagram shows two different tents A and B. Tent A holds 3 people and tent B holds 4 people. Find the number of ways in which 7 people can be assigned to the two tents. So for the first tent, if the person is making the selection, there are 7 people waiting for their turn. So for tent A, selecting 3, 7C3. It could be any 3 because you just have to assign them and they will move into the tent. So 7C3 is 35. So the number of ways of assigning 7 people to the two tents is 35. Now one would say if we start making choices for the green tent, so try that. That would be 7C4. That is again 35. So these are 35 choices. For the second tent, you don't have to make the choice. You just have to tell the remaining people that you may go in the second tent.
By doing 7C4?
Yeah, yeah. This see, the person was making choice for the first tent, and there are 35 ways. And when there are 4 people left, you don't make any choice. You just tell them go there.
Oh, okay. Because it's the blue tent is filled.
If you make first choice for this green tent, you would have chosen 4 people out of 7, and that's 35 choices. Then the remaining 3, you tell them to just go there.
Okay.
And still, if you wish to do the combination thing, you can always say that first 3 are being selected. Now, out of 4, we're selecting 4, and that's 1. So, total ways are 35 into 1 equals 35. 3 coat and 2 dresses to be selected from 9 coat and 7 dresses. Out of 9, we're selecting 3. Out of 7, we're selecting 2. 84, 21, 17, 64. Go through worked example 10.
180, 185. No, 186.
Okay. Sophia has to play 5 pieces of music for her music examination. She has 13 pieces of music to choose from. There are 7 pieces written by Chopin's, 4 by Mozart, and 2 by Bach. Find the number of ways of 5 pieces can be chosen if there are no restrictions. No restriction, nothing. So straight away, 5 out of those 13, and we get 1287. And then there must be 2 pieces from Chopin's. If 2 pieces are already selected, so let me just write it this way. By Chopin's were 7, by Mozart were 4, and by Bach were 2. And we need a total selection of 5. And it says there must be 2 pieces by Chopin's, 2 by Mozart, and 1 by Bach. So 2 out of this, 2 out of this, and 1 out of this. That's again 5. Already 5. So 7C2 and 4C2 and 2C1. So total 5. And this is 252. C part says there must be at least 1 piece by each composer. At least one. So it could be more or it could be less. So if this is already chosen, 1 out of C is chosen, 1 out of M is chosen, 1 out of B is chosen. So 111 is already selected. So that means this is C, this is M, and this is B. So let's say 111 was already selected. To make it 5, if I select complete 2 Bs, this is not going to make it 5. It cannot be less than 1 in either case. I'm making it 3, 4, 5. This is one combination. 3 Chopins, 1 M and 1 B. Now I am reducing this. That's 2. That's 2 and 1, and increasing the other. I'm reducing it even more. 1, 3, and 1. So 1, 2, 2, 3, 4, 5. And it could be 2, 3, 4, 5. So 1, 2, 3, 4, 5. So these are the different combinations, and now we write answer for each of them. Now when we are selecting 3, we are actually selecting out of 7. These were 7 in total, these were 4 in total, and these were 2 in total. So the first one is actually, this is 7C3 into 4C1 into 2C1. Okay, 7C 7C3 into 4C1 into 2C1. I'm getting 280. Now see, if you've punched this in calculator, 7, 4, and 2 stays same every time. This is 7C2, 4C2, and 2C1. I've changed this 2, 2, and 1. So I'm just changing the subscripts in calculator. This is 2 to 1. So 2, 2, and 1 is giving me 252. Then the third one is 131. In calculator, this is 1, 3, and 1 is giving me 56. Then I have 1 total. 1, 2, 2 is 42. And last one is 212. 2, 1, 2 is 84. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All done. 280 plus 252 plus 56 plus 42 plus 84 is 714. I just hope we're getting same answer. 714. Work out 7 into NP, 5 into this, into this, into this.
Sorry, could I quickly just grab some water?
Yeah, sure.
Okay, thank you.
Okay. So, given that 7 into NP, NC5 equals N minus 18 into N plus 1 C6. So, as written in the first part, left hand side, NC5 is N factorial over 5 factorial into N minus 5 factorial. That's one expansion. On right hand side, we definitely need things to look like one on left, so we can cancel them out later. This is N minus 18 copied right away. Now that's N plus 1 is there and base is 6. So N plus 1 minus 6 into 6 factorial. So that's just the first substitution. And now we try to convert it to look like this. N minus 18 stays there. This is N plus 1. The next one is 1 less. So N plus 1 into N factorial, that is 1 less. Now we are just converting the shape to look like that. That's N factorial in numerator. Now in case of denominator, this simplifies to N minus 5 And this is n minus 5 already. And on the other side, this is 6 factorial. If I expand it, I can write it like 6 factorial into 5. So make this 5 factorial look like this. So we can cancel out in the next working steps. Now, once they've expanded, this one could be equated with this. So when we equate them, we can cancel out. See, cancellation, cross multiplication, and we get one straight equation, which simplifies, gives n is equals to 20. Okay, first one says without using calculator, find the value of each of the following. This exercise is actually simpler than 10.3 than permutation. So 5c1 is 5 factorial over 1 factorial into 5 minus 1 factorial. So that's this was general formula was factorial stays outside. 5 minus 1 factorial. So 5 minus 1 is 4. 4 factorial, that's 5 into 4 factorial cancels out, and I'm left with 5 only. So 5c1 is 5. And this is just a different writing style. This means 8c4. Okay, show that 8c3 and 8c5 are same. So 8c3 and 8c5. This is 8 factorial over 3 factorial into 8 minus 3 factorial on the other side. That's 8 factorial and 5 factorial into 8 minus 5 factorial. So that's 8 factorial over 3 factorial into 5 factorial. That's 8 factorial over 5 factorial into 3 factorial. So yes, they're same. How many different ways are there of selecting 3 photographs from 10? 10C3. 5 from 7, 7C5. 11 from 14, 14C11. And that's it. 10C3 is 120. 7C5 is 21. And 14C11 is 364. 10.4 question 3, 120, 21 and 364. 120, 21 and 364. Try question number 4. How many different combinations of 3 letters can be chosen from these?
Five C3.
5C3. And 5C3 is 10. 5C3 is 10. Okay. Now this is the last exercise. There's no subtopic. And after doing this, we're